Hello and welcome to Apropos, a conversation between Clojure programmers that you can join in live on YouTube. We're going to discuss, oh, this one won't be live, sorry folks.
Yeah.
We're going to discuss a few Clojure news items and share our opinions on them. I don't think we have a REPL session, but often we will go into the REPL and code up some exercises. So,
Yeah, all your intro stuff has been,
I know, I have to have a caveat on every sentence.
yeah, every single thing in it. Yeah.
Yeah.
But
Ever
it's good.
since Google got rid of that YouTube Live or whatever they called it,
Yeah.
Hangouts on Air, they kept
It's-
changing the name anyway, moving the
Yeah.
buttons.
It was just
Okay,
Yeah.
so I'm Eric. This is Mike.
Howdy. Yeah.
It looks like it'll just be us two. Mia might be joining us later. Cool. So we talked last week about the new A History of Clojure paper that
Oh, you printed
was
it out.
published.
Yeah.
You can get to the show notes. We'll put those in the YouTube description. There'll be a link to download this paper. This was a paper that Rich Hickey was going to present at the History of Programming Languages conference, which is an occasional conference.
Yeah, it's like the cicadas. They come out every 17 years.
Yeah, it's like a prime number, like,
Yeah.
so that it doesn't conflict with other
Yeah. Other
conferences.
predators. Yeah.
So this is one that's run by, I think, Richard Gabriel and Guy Steele.
Oh, man. Yeah.
These are two names in the Lisp world that we are, we're often familiar with. Richard Gabriel was one of the folks at Symbolics,
Oh, really?
which was
Wow.
one of the Lisp machine companies back in the 80s, and also a big Lisper. And Guy Steele was very instrumental in developing the scheme language, also wrote Common Lisp, the language, the sort of manual for Common Lisp. So two really big Lisp people who are also interested in the history of languages.
I think I heard of Guy Steele's name first with the one of the Java specs or books or.
Yeah, he wrote the Java spec.
Yeah.
He
That's
wrote the
where I first
Java
heard
spec.
of it, Yeah.
Yeah,
Mhm.
about that, someone asked him like how he could do that, and he
Yeah.
said like, well, they called me up and said you're good at writing specs. Would you write the
Okay.
Java spec? So he didn't do the language. He just wrote down what it did
Oh,
in a
okay.
good way.
Do you remember the quote, something along the lines of, at least Java's dragging the people halfway from C++
Right.
towards Smalltalk? I don't know if those are the two languages, but it was
No,
something.
it was like the Lisp people felt betrayed because of course
Yeah, he's given up on
religious wars and stuff about programming languages still going on. But he said something like, Java is dragging Lisp people or C++ people halfway to Common Lisp. Aren't you happy,
Yeah,
right, that they're getting that? Because he's a
like
very
garbage collection
language.
and stuff's in there. Yeah,
Exactly. He's a
lot of things, right?
positive person.
Yeah.
Yeah. So, um,
So he runs
we
this
should.
conference along with Richard Gabriel. Yeah.
Right. So Rich Hickey was invited to give this talk. So I think that's important background to know that these are like, I mean, I've never been to this conference and I've never read another paper at the conference, I don't think, but it's got to be kind of Lisp friendly. Like you'll find a lot of Lispers there. And so a lot of, not all Lispers, but like a lot of them, because the two organizers are pretty heavy into Lisp. But the paper is largely for people who don't do Clojure, and to kind of it characterizes Clojure and the design decisions behind Clojure. It's not written for, you're a Clojurist and like you're wondering like why does Clojure do XYZ. That was my interpretation of it. And so a lot of it is comparing Clojure as like, you know, it is a Lisp, but it differs. It takes a left turn at some points. And that's the stuff I think is really fascinating.
Yeah, a
Um,
lot of it like summarized the language rather than so much like
yeah,
a historical standpoint. Just like
yeah,
kind of
yeah,
went through the big
exactly,
features in the language, which is cool. Yeah.
exactly. Yeah, and yeah, so we're just gonna talk about some of this stuff. I didn't think that there was any like big surprise. A lot of the stuff that he talks about, he has mentioned in talks. Um, or, as a Clojure programmer, probably our audience would already know that, Clojure has persistent data structures, so it doesn't need to be mentioned.
Yeah, and I think I remember reading that he's like this wasn't his first Lisp attempt, and
Right,
he tried several times and when
right.
stuck, I guess. Yeah.
Getting disillusioned with static typing.
Yeah.
Um, yeah,
Yeah, he
which,
was teaching C++ heavily back then. And yeah.
yeah, yeah. He doesn't get too much into it. Man, I wish I had like highlighted passage. It's very long, so I
Hmm.
can't just like flip through and find the passage,
Yeah.
but
Yeah.
he talks about how he thinks it's a mistake to bake the domain model into your code. Um, so like a lot of times you'll have the database has its own model of like, your domain, and then your code has a similar model, but it's not exactly the same, and so you have this um, mismatch between the two, and you have a lot of code that's like stuck in this certain model.
Mm.
Change the database and the code at the same time. So
Hmm.
so that that made me think a lot about like how Clojure programs tend to be, where it's just sort of like let's just get the
Yeah.
data out of the database and transform it. The
Right. And you have
database
no,
is
yeah.
go ahead, sorry.
You have no like def records basically, or classes
Right,
in C++
right,
that bake
right.
in these, like you don't calcify your code base. You're just more flexible. And
Exactly,
yeah.
exactly. That makes a lot of sense to me,
Hmm.
especially the idea of like having it in one place. Um, you know what I mean? Having the data model defined in one place. And his idea is it shouldn't be in the code,
Okay. Yeah.
um, in the software itself. Um,
Yeah.
yeah. So I wanted to, and feel free, Mike.
Right.
I
Yeah.
I wrote I wrote the notes, so like
Hmm.
I
Yeah.
kind of just wrote a bunch of stuff in there to make sure we had enough.
Points to talk
Um,
through. Yeah.
yeah. So I'm looking at this section 3.1. Right, the section 3 is initial design and language features with rationale.
Hmm.
This is before release, right? This is all the decisions he had to go through
Yeah.
before for 1.0. And so he's talking about um, how Clojure is a Lisp. Like, what did it take from Lisp and bring forward into Clojure? The first one is code as data.
Hmm.
Um, Uh, so I want to talk a lot about this because, that's one of the defining things that people say about Lisp, that code is data. Um, but he kind of extends it further to say that like code, like macros that take code and transform them into more code is just one possible example of data to data transformation.
Okay.
And that starting with code as data is like a good way of proving that you can do the flexible data transformations.
Hmm.
I don't know. What do you
Is
think about
this
that, Mike?
is this the part where he talked about adding data literals for maps and vectors, or was that later on in the
That's
that's
later.
that's a different notion, I guess. Yeah.
Yeah, yeah. But
Hmm.
he talks about in this section about putting symbols and keywords that
Okay. Hmm.
um, you need some way of representing names of values, um, and just to be able to write the language.
Hmm.
So I thought that was
Yeah.
interesting.
I guess one thing for me, at least, for code being data, is the structural editing that you get in editors.
Yeah,
I
sure.
guess you could get that from other languages, but it seems just so natural, right? In this kind of a language where.
The problem is you have too many types of structure, right? If you just have parens and
Hmm.
maybe, you know, now in Clojure we also have square
Hmm.
brackets and curly brackets. But
Hmm.
it's a few no, it's a few.
Right.
You can actually learn enough keystrokes to do it. But if you have different types of structure like, oh, I need to open parens or I need to create a block or I need to, make an if statement or I have to, it's like too many
Yeah.
keys you have to learn.
Hmm.
Okay.
So, yeah.
He talks about read and print, which um, and separated it from the compilation and evaluation of the code.
Hmm.
Uh, that's another thing about Lisp is they have this read about print loop. So once you've read in the data structure, which is essentially parsing into data, then you have a separate step that will compile it, and then another step that actually runs it. And a lot of languages, you know, they don't give you that
Right.
separate parsing compiling step. That's all done at one time at the beginning, and then when you run it, you run it separately. And that gave the eventually led to Eden because the reader
Oh,
was
okay.
separate. So that's interesting.
Huh. Yeah.
A small core language. Um, yeah, he wanted it to be like not have a huge
Right.
cognitive load,
Yes. Yeah.
which I think is a huge like feature that's not talked about that much.
Yep.
That
Hmm.
that problems are complex enough by themselves. Like you don't want to have this other complex language that
Yeah.
put on
I
top.
remember trying to completely get C++ into my head and all the little twists and turns of that language.
Mm-hmm.
And then you kind of like come away with like, let's not use certain parts of that language. Let's simplify C++.
Subsetting,
And
yeah,
it's still an extremely like a big chunk of my brain was spent on that language.
yeah.
And like all the decisions, do you use reference types or whatever they were, or put something on the heap or put it on the stack, and like all those little
Mm.
decisions over and over again. It's like I remember like spending an inordinate amount of time
What type
reading
of
books
ref
on
do
that.
you use and
Yeah,
create
yeah. And then I
smart
remember later
pointers?
on when I was getting into functional programming, I felt the same way about Scala. Like, man,
Oh,
this language is really, really, really getting complicated.
yeah,
And I was cool with that because I was like, I was not used to anything else, right? I'm like, yeah.
right.
Um, but then Clojure is like astonishingly simple. You can like
Yeah,
you can fit it onto your head and then move on with life.
that's right. That's right. And I think that most places will subset languages
Hmm.
because they are too much to handle. And what's interesting about Clojure is that has been done for you. Like
Yeah,
even if you do subset it, which I do, like I don't use the
yeah.
whole language,
Oh yeah, even
but
Clojure has like corner cases that you don't want to
I
use
never use
or
def record. I never use protocols. I
yeah.
never use multi methods. Come on.
It's exceedingly rare when you pull out those tools. It's like that.
Exactly.
There is like this core set that you even use within Clojure. It's
Right.
even
It's there when you
I
need
can
it, but rarely, rarely.
yeah.
Um, that is actually the thing that when people ask me
Mhm.
what closure is for,
Yeah, yeah.
like people have this idea about general purpose languages having a specific purpose.
Mhm.
Like, oh, Ruby, that's for web programming, and Python, that's for machine learning. Um, Clojure doesn't have one of those. And so this is my go-to answer because at least it keeps the conversation open. It's interesting. I say it's the point of Clojure is to be simple because your problem is complicated and you don't want to add to the complicated, you know. And they're like, huh, oh, that okay,
Yeah,
there you
it
go. It's for
reminds me of
complicated problems.
like especially when you combine that with a REPL, it reminds me of using MATLAB when I was in school. That's a
Mm,
little language for matrices, and it's got
mm-hmm,
literals for matrices in that language.
mm-hmm.
Clojure feels a bit like that, where it's like, this language is so simple, I could actually teach it to my kids. Like,
Yeah.
there's a few constructs, and they can actually produce functions and code a little bit, and you don't have to get all wrapped around the wheel with like the nth degree of learning all the corners of the language to get going in it. Uh,
That's another thing. Like, if you, some languages, I won't name any names, but I find that the mastery of the language requires, what, this is what it's just like an anthropologist, like observing, like, let's say two Ruby programmers, or maybe a group of Ruby programmers, where you can kind of see what the values of the community are by what they kind of compete with each other about. And it's like knowledge of like, do you use a block or a lambda or oh, if you use a lambda in that case, it's got, it doesn't bind. I don't know Ruby, but they have all this like
okay.
minutia about like what to do when and which construct that's very similar to the other construct you should use in which
Yep.
situation.
Yep. Yeah.
And it's sort of like a point of pride that they have it all internalized.
Yeah.
And I look at that like that's a problem with the language. Like the thing is it creates a lot of Stack Overflow questions and
Mm-hmm.
uh you know it's one of the things that people have been talking about recently is like maybe it's not a good thing that there's a lot of Stack Overflow questions about your language because that means people don't understand it easily.
Yeah. Yeah.
All right,
Yeah.
so the next one is tangible at runtime. So this is that namespaces are just collections that are accessible at runtime, and you can enumerate them and all that stuff. So it's
Mm.
like this idea that the language constructs are just data structures with with API that you can access, at runtime.
Mm-hmm.
Um, that's a really cool idea.
Yeah. Thinking
Yeah,
about ClojureScript, you have to give up a little bit on some of the reification of things, but for a good reason, you need to.
right.
But you get all that in the REPL at least when you're developing, or
You
most of
get
it.
it in the REPL, which is when it's important, right?
Yeah. Yeah.
The next one, REPL.
Mm-hmm.
Uh,
Yeah.
yeah,
That's
this
that's a
one,
profound thing that we all need.
yeah. I think the main design decision there was, besides keeping the read and the eval separate, is to um, eh, make it a single code path, whether you're typing at the REPL at the prompt
Mm.
or you are loading a file,
Oh, okay.
right? So it's not like there's a
Mm-hmm.
separate mode you're in, like I'm in the REPL mode, that
Yeah.
the
Yeah.
semantics are different. It's the same code path. It's
Yeah.
just
That's
there's a
true.
prompt waiting for each line as opposed to loading it all, streaming it from a file. Um, which is, I think that might be the one thing I would say, like if someone, because a lot of people are like, oh, isn't the Python REPL a REPL? Or like I can pull up the developer
Okay.
console in the
Like a
browser
JavaScript
and
REPL. Yeah.
yeah, I have a JavaScript REPL, but it's sort of like, yeah, but you're in this different mode. You are not,
It's
um,
abnormal, I guess, to be in that mode.
yeah,
Yeah.
it's probably a different code path. Like it's probably accessing the same compiler and everything,
Mm-hmm.
but it's this other thing. Um,
Yeah. Okay.
yeah, yeah. Flexible. Yes. This one is that he didn't want to bake in a programming model, right? No object-oriented programming, no category theory, a type system that forces a certain kind of way to program.
Hmm.
That it was a deliberate decision to leave all of that out because he thought that they weren't suitable for the kinds of programs he worked on,
Okay.
and that their cost-benefit ratio was not great. And he's like, you're
So
free to add that in as a library.
yeah,
So,
because that keeps the
core.
core language smaller and simpler to
Hmm.
understand. Yeah.
Right. And it's optional.
Hmm.
If it's not going to work for your problem, don't do it.
Yeah.
I appreciate that. It's one of those like decisions of what to leave out, um, where he could have specialized the language and said, this language it's about what's an example? It's about building ORMs, or something like
Right.
that.
Yeah.
Like, and so you have this like object model that works really well with databases, something. But he didn't do that.
Yeah, like if there were ever like this idea of a next version of Clojure, it would be like cool to take things out of it
That's
to,
right.
to
I think it
subset
would
it,
be a lot. Yeah, yeah. He actually has a section near the end about his regrets, like what he would do
Yeah.
differently.
But
We
since
could
it's
go
like
over that.
aimed at production, you don't want to ever remove anything. But if you were like
Mm,
daydreaming about that idea, you
yeah,
could be like, yeah, remove things. Like the
that's
STM.
right.
I never used the STM.
Yeah,
And that
he
was like a
talks
big
about
thing
that.
back then. Yeah, he does. Okay.
It was huge. It was one of the reasons why people thought
Yeah.
like started using Clojure. They got excited about it. But yeah, who uses that? And he actually has a statement in this history about like it's coming up with there's this matrix, a grid of the concurrency primitives, atom, agent, and ref. And there's two axes.
Yeah.
There's whether it's coordinated and whether it is serialized or it happens, no, sorry, synchronous or asynchronous.
Yeah, I remember seeing that chart. Yeah, yeah.
Right. So one
You
of the
could put each one
boxes
in
is
the
empty.
quadrants. Okay. Yeah.
Exactly. One of the boxes is empty, but then agents are asynchronous
Hmm.
and unsynchronized. Atoms are synchronous because it happens in your thread.
Okay.
You don't return until it's done. So it's synchronous and uncoordinated. And
Okay.
then refs are synchronous, still happens in your thread, but they are coordinated. You have two refs, you can get a transactional, like you can read from one and write to the other in a transaction way.
Yeah. And I guess in my simplified thinking, that was like the transferring money from one account to another problem.
Yeah, right. The
But
the transaction problem.
if you say there's no two separate places for the data to be, it's all one gigantic map, then you win. You get rid
That's
of them.
what
Yeah.
that's what most people get to eventually. They're like,
Yeah.
oh, I just need an atom
One
where I just
single.
put everything.
Yeah.
um, but what he says is like, the the work that was done on the refs, like most people don't use them. But
Right.
was it worth it? And he said the thing is when you need the coordinated state,
Hmm.
you need it. That's exactly what you need. So it's like it fills a strong but rare need.
Okay.
Um,
Yeah.
like you would have to choose something else. You'd have to have some external system that you relied on, something.
Hmm.
And so this lets you keep it in there for those rare
Yeah.
times. Yeah,
Yeah.
it's interesting.
Rich must have invented at some point was and it's not really in the language, maybe it's in the library. It's that whole idea of like the update functions when you're updating a ref and that pattern
Mm,
you go through,
yeah.
update some map and the
Uh-huh.
keyword and then ink or whatever, that
Yeah.
little mini language that you come up with.
Right.
That when you first hit that, you're like, what is this? You have to
Yeah,
learn
it
it
moves
because it's,
a function over here, and then the
yeah.
first argument gets put in. It's
But then
weird.
it grows on you because you like it kind of reads nicely and you get used
Right.
to it, and that
I
feels like that's a
wonder
very good thing. Yeah.
that it is neat. I wonder if he has a story about that because you can see
Mhm.
like
Yeah.
if you look at it like, say, from a JavaScript programmer's perspective, right? It's like,
Okay.
okay, you have this atom, so you're gonna do swap. Well, obviously you're gonna pass it the atom. That's the like
Mhm.
thing that's swapping. And then you're passing it a function, right? And you're like, this is great, except then you realize, hey, all the time I have to make this anonymous function to pass in three other arguments, right?
Mhm.
And so why don't I just put those other arguments after it?
After, yeah, yeah.
But then things get in the wrong order, right? Yeah, interesting.
I feel like some of those kind of things are, I almost feel like I take them for granted now, but they must have been hard for Rich to come up with, or
Yeah,
whoever was involved
yeah,
back then. They're like,
right.
oh man, they're very simple ideas, but they're just core to everything now.
Yeah. I wonder what it would look like to move the atom to the second position, you know?
Mm,
Because then it would keep everything in the same order. You'd have a little bit less confusion.
mm.
Maybe in version 3 of Clojure.
Yeah.
Uh, okay, so I'm just going to go down the list.
Yeah. Okay.
Um, there were some things that different Lisps have already kind of innovated on and made different decisions about. There's like divergence. And so he had to, you know, pin these
Opinions. Yeah.
decisions down.
Yeah.
One was that it's a Lisp
Yeah. Yeah.
one namespace for both values and functions. Just as history, Common Lisp is a Lisp 2, there's a
Hmm.
separate namespace for functions, which is kind of neat because it means you can name, like, so list is a function, right? You can name your argument list, and you can still call the function list. Whereas in
Yeah.
Clojure, because it's a Lisp 1, it
Mhm.
shadows it.
And I have never programmed in a Lisp too, but does that like kind of like make the syntax a little more complicated at times when you
Yeah.
have to like indicate that you're calling a function as opposed to
Yep.
yeah.
Yep. So when you're passing the function,
Mhm.
there's like a reader macro,
Mhm.
a syntax that's the in Clojure, it's the var syntax. It's the hash
Yeah, it's that.
apostrophe
Yeah, yeah.
that means I want the function version of this symbol, right? Look it up in the function namespace, and then when you call it, you have to do um, fun call. So you have to
Okay.
explicitly tell it call that. There's another function called fun call, and
Yeah.
it's it's so much
Okay.
easier to do functional programming with the Lisp one.
Okay. My naive takeaway from all this is that it feels simpler in Lisp one.
Hmm.
Because there's nothing weird about any of this. They're all the same. Functions and everything else and data structures are all the same, and you talk about them in the same way, and you call them in the same way. It makes
Yeah.
functions feel more first class, I guess, because they are no
Hmm.
different than
Definitely.
anything else. Yeah,
Definitely. Definitely more first class.
I guess there
Yeah.
could be arguments for a Lisp too. If you maybe there's pros and cons on both sides of that.
I
I'm
mean,
sure there must have
common
been heated
Lispers
debates.
like it.
Yeah,
Yeah.
yeah,
Just we'll talk about this in a second, but just like how in Clojure there's a explicit tail recursion, it's
yeah,
explicit, and us Lisp or schemers are like, but don't you want it everywhere? Why do you have to be explicit?
hmm
Um, yeah, it's definitely sometimes it seems better that it's explicit, sometimes it doesn't.
yeah.
Um, Macros.
Okay.
So Clojure has let me back up.
hmm
So Common Lisp has regular macros, meaning there's not much special about macros. Like you get some data structures and you output a data structure, you return a data structure, and like that's it, right?
Yeah.
There's not much going on. And the problem is
hmm
because you're outputting different code, you're going to have symbols in there that are different, and so you might shadow a thing that already exists. And so there's like whole chapters of books like how to avoid this problem, how to
Yeah.
avoid that problem. And
You
so
could easily shoot yourself in the foot. And, yeah.
exactly.
hmm
and you have to do gen sims. You have to generate a random symbol that hasn't been
Hmm.
used before because some other macro that is above you is
Yeah, yeah.
doing macro is generating symbols too. And so like yeah, there's a whole thing, and so you have to learn all these patterns like
Hmm.
okay, do a let gen sim and then store it in a variable and then you can access that variable later. Okay, so what Scheme did was they were like, this is nuts. Like, there's so many errors. We
Hmm.
wanted to be safer to write more macros. And so they have what's called hygienic macros.
And that's where all this came from, was Scheme,
Well, in
or
Scheme,
most of
yeah,
it was.
the hygienic macros are Scheme. It's
Hmm.
much more like we're going to do very strict pattern matching,
Hmm.
and there's rules that are checkable about what you can output based on what's being given to you, that kind of thing. And the end result is that macros are easier or they're harder to get wrong because of the checking, right?
Yeah, yeah.
It, uh, so that means that you could probably do more complex stuff and be more confident that you get it right.
Hmm.
But then it's a real pain. It doesn't feel like you've got the whole language on your side. You're in a
Yeah.
different language almost. So what Clojure did was, I think, really awesome because I've done Common Lisp. I've done a little bit of Scheme, but I could never figure out the macros. Clojure solved the major problems with Common Lisp without throwing out the ability to use all of Clojure to to write them. So that's like auto gen sim, right? Also that Common Lisp, the reader interns the symbols, which what that means is the symbols in the namespace have a
Oh,
storage location. And
okay.
so when you read a symbol, it will in the namespace say, okay, this is where its value will live,
Okay.
right? So then that lets you it's neat. It solves a problem, which is you can do forward references. You can refer to a function that doesn't exist yet, refer to a
Okay.
variable that doesn't exist yet, because the storage location has already been created when it read in.
Oh, okay. Okay.
Um, but with macros, the problem is that um, you are because the reader is able to affect your state,
Hmm.
basically. Like it just creates this real problem. And so you in Clojure by having symbols be divorced, there's just a pure name, just a piece of data. It's like a
Okay.
string with a wrapper around it, right?
Yeah, yeah.
It means that um, things can get uh, thing that is decoupled basically.
Okay.
Okay, and
Yeah.
so then the thing that the reader does though is it will qualify things with the namespace in Clojure,
Okay.
and that avoids uh, the shadowing problem. So if
Hmm.
I in my macro name something map, the reader is going to
Hmm.
read it and convert it into clojure.core/map.
Okay.
And now it's not going to get shadowed because it's fully qualified,
Okay. Yeah.
right? So then there's a little bit of syntax. There's the like auto gen sim where you put the hash
At the
symbol
end.
at
Yeah.
the end of the name.
Hmm.
That automatically creates a gen sim,
That's just a nice
and
syntactical thing. Yeah.
it's a nice thing to, but it's checkable
Oh,
because
yeah.
Clojure
Yeah.
will say, this thing doesn't exist. You can't use
Yeah.
it. And so then I forgot to put the hash symbol, and then it works.
Yeah. Yeah. Yeah.
So it solves all these problems
Hmm.
in a roundabout way. But what the end result is the macros still feel like I'm just doing data processing. I'm just transforming data.
Hmm. Yeah. I guess you would almost, at least for me, I would have to go program in some other Lisp and feel the pain to appreciate what Clojure has. And to
I've
be
been
honest,
there.
I don't write macros often enough.
Right.
So every time I go to write it, I do feel like I'm in a different world, and I have to be careful.
Uh-huh.
And things slow down for me. I'm like okay, let me get this right, because this is a macro now. But it's
Yeah.
like so rare that uh,
Yeah. It's very
it's
rare.
it's not a problem. I can still write them. But it's
Right.
like it's a thing that you don't do frequently enough, like you're writing regular functions all the time, right? Um, and
Hmm.
and you don't often need macros, so
No. No, it's
um,
it's really it's really interesting somehow. I
mhm.
remember coming into Clojure being like, "All right, let's do some macros."
Yeah, it's like when
Because
you're
that's
new
like,
and you're learning it. Yeah,
yeah, yeah. But like
I
in
went through that
Common
phase
Lisp,
too. Yeah.
you would do macros all the time. And I don't know if this is right. It doesn't feel
Hmm.
like, yes, I really nailed it. But there's something about having a more functional style that feels like you don't need macros so much.
Hmm.
Um, the idea of creating an anonymous function really succinctly that you pass to something instead of like in Common Lisp, you have all these macros that are like with open, you know? Like you could do a with open, the with open macro in Clojure?
Yeah. Hmm.
Like it has a binding form
Hmm.
and you pass it some reader or something that can be closed, and it runs the body, and then there's like a try finally around it. So if anything exits, it will close the thing you bound, right?
Yeah,
Well, you could easily write that as a higher order function,
yeah. That takes like
right?
a little thunk or something like that, and
Yeah, it
whatever you
takes
want
a
to call
thunk
that
that will
idea.
take the reader,
Yeah.
and
Hmm.
and
Yeah.
the thing is, like, I feel like I do that much more now because it's the functional programming stuff is much easier. I don't feel
Yeah.
like, oh, I need a macro to like
Right.
get rid of this ugly syntax.
Yeah. Yeah, to me, it feels like macros are largely used to define some of the core libraries we use all the time, and they
Hmm.
become part of they like extend the language a little bit. I don't use it to extend my own. I don't like make my own languages while I'm programming, I guess.
Right,
That's
right.
that was like a Paul Graham thing, right? Like you're building your own language to solve your own problem, and
Yeah.
uh,
And like
and
honestly,
mhm.
well, like I think so. Hiccup is a good example where because you got a variety of data structures to choose from, uh, you can make a language that's it's just pure data, right?
Yeah,
Using literal data structure. Whereas in Common Lisp, to do that, you would only have parentheses,
yeah.
and you would have to be quoting and unquoting all the time.
Yes,
And
yes.
so you would be like, this is a real pain to get right. It's not just like a pain like my fingers hurt from hitting the back tick,
Yeah,
a lot. It's like you get it wrong a lot. You forgot to unquote or whatever.
yeah.
And so you would write a macro, and you would
Hmm.
make your HTML macro and a head macro and a body
Yeah,
macro.
to help you,
And
yeah, cope with that. Yeah.
exactly, so that you could nest them together, but also have them, you know,
Yeah, yeah,
yeah. So,
yeah. And speaking of that,
uh,
every new Clojure user goes through that, and they immediately zoom in on the macros. It's this powerful thing,
right.
and it takes you a while until you realize everyone's telling you, no, the power's on the other end of the spectrum.
Yeah,
It's the
yeah,
data that's the power. Yeah, and then you finally get it, and you're like, yes, this is
exactly.
simpler. Yeah.
Yeah, exactly. And I
Yeah.
think that that's a useful exercise,
Hmm. Oh yeah.
to really dive in and like really figure out where's the limits of these macro things. But
And
yeah,
even one nice thing about ClojureScript too is that little friction you feel because in order to make a macro, you can't just do it right there. You got to go
uh,
to another namespace, and it's
right,
like you're gonna have to commit to this. If you're gonna think about making a macro,
right.
you need to go make a whole other namespace and put that in there instead of directly in
That's
line with
right.
your code. It's just another impediment to making a macro. It
Right.
wasn't done on purpose, but there's
Right. And
reasons,
it's usually not
Yeah.
needed when you've got the literal data structures and the functional
Yeah.
programming.
Yeah.
Wait, what's next? Okay.
Okay. Yeah,
Reader
okay. Yeah.
macros.
Redo
So
macros. Yeah.
yeah, so Common Lisp has this extensible system where you
Hmm.
can say, well, when I write this weird symbol,
Hmm.
call this other function to read the next thing.
Yeah.
And um, that's again one of these things that he left out And I think for good reason. Like you talk to companies that use Common Lisp, and they're like, yeah, there's one place where we use it, and it's not that
Okay.
important.
Yeah.
So, like, just as an example of where people use it, um, the company that was bought by Google that was doing all the flight search. I can't remember what they're called. Um, anyway, they had the best flight search. Like if you wanted to get from Miami to Tokyo, and it would show you all your options. Do the graph traversal of all the possible flights. Um, and that was written in Common Lisp, and they use it in one place. A huge production system. They use reader macros to make it easier to type in the names, the three-letter
The airport
call,
designators. Yeah.
yeah, for airports. Yes,
Yeah.
exactly.
Okay.
So, so
So
like
yeah,
where we would use a keyword or
a
something.
keyword or a string, one of the two.
Yeah,
Just keep it simple, I guess. And
exactly,
yeah,
exactly. Um, well, there you go.
yeah,
Uh,
it's like that's one of the things that if it wasn't in the language, I could live without. I guess I like
hmm
the inst and the
hmm
date kind of
Well,
inst and the
that's the other
UUID.
thing is he figured out a better thing.
Hmm.
Like you don't really want this ability to redefine the syntax. You just want one more piece of syntax that lets you put a bit of semantic meaning on the piece of data,
Yeah,
which I think is just right. That's exactly like if you could just type pound airport,
yeah,
you know, and
yeah.
then give a symbol, like
Yes.
that would be it. That's all you would want. Instead of
Yeah.
like pound less than bang, whatever
Yeah.
symbols they're using.
Yeah. So if you really, really need this feature, it's there.
Yes, exactly. Um,
Tail calls, huh? Tail calls and recursion are the next on the list.
tail calls and recursion.
Yeah.
So this is
Yeah.
a big one because Lisp, I mean, functional programming really needs tail calls.
Yeah.
Um, but
Yeah.
he couldn't find a way to do it
Hmm.
that he liked, basically, that was not um, because of the way things are compiled
Yes.
to JVM bytecode and stuff. The
Hmm.
JVM doesn't do it automatically.
Right.
And then there was this other issue of when they're implicitly removed, um,
Yeah. You don't
people
know that you're
don't
not in a
know.
tail position. Yeah.
Yeah, yeah. I mean, you can trace through the code, but like, it's hard to know.
You all of a sudden have
And
a performance bug and you don't know why. Yeah.
exactly, exactly. And you're hitting Stack Overflow and you don't know.
Hmm.
So he decided to make the recur thing, which is
Yeah.
explicit tail recursion, which is easily detected. So if you're not in tail position, it'll tell you.
Yeah. And I guess one interesting thing is that Clojure is a hosted language. So, when it moved over to JavaScript to make ClojureScript, this was one thing that was good that it wasn't relying on
Yeah.
something weird about the host.
Right,
It makes the
right.
language more portable. But even without that, I'm fine with this. Sometimes you run into like weird things where you need mutual recursion and you reach for these trampoline things and whatnot, and your
Right,
mind starts to explode.
right, right.
It'd be kind of nice if it just did that for you, but
Yeah.
stuff's
I
hard enough
mean,
to think about as it is.
exactly, exactly. Yeah, he talks. Let me
Yeah.
bring up a detail I missed.
Okay.
So he could compile it so that it did explicit self tail call, not implicit, right?
Okay.
He could do it to, if a method called itself, he could turn that into a loop in the bytecode. But he
Yes.
couldn't do it with mutual calls.
Okay. Yeah.
And he felt like that was bad, right? That
Have
you
this
make
implicit
something
thing
a
that only
single.
works. Yeah.
What's that?
He thought it was bad that you would have this implicit thing that only works in certain contexts. But
Exactly,
when
that
it
the
came to
mutual
mutual,
tail calls need to work too, and then you'd have to explain why the mutuals don't work, and you'd have to like, so, if
yeah.
you had a function or a method that called itself
Hmm.
and you decided to refactor it, and part of that refactoring was to split it in two, now it becomes a mutual tail call
Yeah.
that's not going to get optimized,
Yeah.
right? And you don't even know. Like all you did was split a function in two. So that, I could see why you would not want that surprise there.
One thing that one comment I have is I don't like the name loop. Um, it's okay.
Mm,
I don't, it doesn't, I now know the language, so it doesn't bother me anymore. But when I was first learning it, it's like, it calls out the vulgarity that it really is. It is it's turning it into a loop at the
yeah,
machine level. Maybe that's good. Maybe that's the intent. Because that's what it really
yeah.
does in the end. But I'd like a more lofty name for it. That's like,
What would you call it?
I don't know. It's like the recur target, right? It's the
uh,
so it's like there's this argument that loop recur is a very functional construct,
mm,
but yet you know that it turns into an imperative loop at the bottom. But you can ignore that. Just stay up at the high level and think about it as a functional construct that makes it easy to like refactor your code
yeah, yeah.
around. Um, so just the loop is like, oh man, it's calling it what it really is at the machine level.
Sure, sure. It also does this neat thing with the recur,
Hmm.
by having a special name that always means tail recursion. It lets you write an anonymous tail recursive function,
Yes, yeah,
which you couldn't do. You'd have to come up with a name so you could call it
recur to it. Yeah,
self.
yeah.
That's pretty cool.
Rich did say in his paper that the choice of the name loop helps newcomers when they're looking for a loop construct. They'll hit upon
Oh,
this idea,
and
and
then they
and
have to.
they're like, I want an imperative loop. I'm like, well, here's you found it. You know,
Here's what
this
we
is the
got.
closest. Yeah, yeah.
That's true. Hmm.
That's a minor thing.
Um,
Yeah.
yeah, no, it's true. It's Googleable.
Yes. Yes.
Okay, and then there's three differences that he talks about. One is abstractions at the bottom.
Hmm.
Um, he talks about how Lisps are traditionally defined in terms of const cells, like everything
Yes.
is defined in that.
Constant. Yeah. Hmm.
And he says he wants to have the seek abstraction lower down in the const cell. That makes a lot of sense to me. When
Hmm.
I have like this dual background of Common Lisp and Clojure, and I feel like, Common Lisp and Java. I feel like Java got a lot of that right with the collections library of like doing a lot of stuff with interfaces, instead of with concrete classes.
Hmm.
And I think that this was a cool thing.
And when you go to make like map literals or just the map data type, it's cool that
Hmm.
that's an abstraction that you can, it's tucked
You can
away inside
implement it.
there.
Yeah.
Yeah.
Hmm. And then seeks and laziness. Um,
Yeah.
right. So, he's got this seek abstraction. It's an interface. But it gives you the same like Lispy feel that you often get of like cursing down lists and stuff. And it's interesting. Interesting. Um, we all know about laziness in Clojure. I don't think we need to talk about that. And then the last one is functional. Um, Man,
Okay.
Clojure is way more functional than Common
Yeah.
Lisp.
Right.
Like, even though Common
Hmm.
Lisp, you know, I would say, yeah, it's a functional language, but like, you just don't do as much. You do a lot more of like updating in place. You do a lot
Okay. Yeah.
more, like, like one of the
Destructive. Yeah.
yeah, yeah, one of the common recommendations is like you have a list, the
Hmm.
linked list on
Okay.
cells,
Yes.
and uh, one of the things to do is you loop through and you build it backwards, but because you can modify it, you can add the rest on later. Like as you,
Hmm.
yeah, it's more efficient, right? Because you can
Okay.
do
Yeah.
a forward loop that doesn't use the stack. It's a tail recursive call, tail call.
Hmm.
Um, but it builds it forward, uh, by changing the cutter of the const cell.
Oh
And
man. Yeah. Yeah.
so you're doing imperative programming,
Hmm.
and um, Of
Yes.
course, back then it was important because you needed efficiency and stuff, but it really felt very imperative.
Yeah, so there's this argument that if you had to give up certain things in Clojure, you would want to keep the persistent data types.
Oh yeah,
They're much more important than the syntax. If you had to program in Java, you would like the persistent
yeah.
maps, and
Give me those things. Yeah.
because it's just no, the conceptual burden of dealing with those is so low. Um, it
Yeah.
leads to sanity. I guess there was there was a Twitter thing about immutable data structures lately, and I don't know if you
Mm,
saw that one fly by. People were like debating like what's so uh, why does immutability help you so much? And
mm.
it's like yeah, it's the without that you have the go-to of data, I guess.
Yeah.
Mutability
I,
just hurts. It's
that's
like
right.
a rock will always be a rock. There's nothing to talk about it. It does not change. It's simple to understand.
Well, it's a simple. That's right. It's like it doesn't break our conceptual understanding of the world, like our commonplace physics idea. That like I wrote something on a piece of paper,
Yeah,
I put it in my pocket, and when I come to it later in the day, it has not changed,
yeah,
right? Like I was there the whole time. It never left my pocket. It should be the same. Like if you've got a piece of paper and you give it to someone else, but you also have like somehow magically you have it in your pocket too, which is what happens when you share memory that's mutable. Like they could write all over it, they could change it, and you open your pocket and it's different.
yeah, yeah. Immutability just leads to so much simplification and
Yeah,
ability to reason about things, especially when it comes to multi-threaded programming.
yeah.
Leads to sanity. Yeah.
Um, right. So there are a couple things more that I have written down. Metadata. I never use metadata. Do you use metadata?
I think it's one of those things that I thought was cool when I learned the language, and in my more
Yeah.
mature self, I don't use it. yeah, yeah.
I find it
I'm
a
always
little
afraid that
difficult to work with.
I'm afraid that like relying on it, that it's easy to accidentally lose it as
Yes,
you're
I
passing
agree.
data through things, and like it might get stripped off somewhere along the way. And so I never want to like build something that absolutely relies on it. Um,
That's right. I agree. I have the same fears that like, the idea of putting metadata on something so you like know where it came from.
yeah,
Clojure does the right thing. I one day sat down and I did this. If you've got a set,
hmm
and like let's say the set has a vector in it that has metadata on it, okay? And then you have another vector that has no metadata, but it's equal to the thing that's in there. If you
yeah,
put it in there, it doesn't replace the existing one.
okay,
It use this the one you had in there before is still in there,
hmm
right? So that means that the metadata on the one in there is what stays. 'Cause, if you're like
yeah,
just
okay.
adding stuff to a
Yeah,
set,
so
right?
it's like, yeah, there's special rules surrounding metadata and how it survives. And yeah,
Yeah, but like if the one that has this one has metadata and that one has metadata,
yeah,
you're
yeah.
throwing away metadata.
Okay,
You're
yeah.
throwing away the new one, the second
Yep.
one.
Yeah, it's a
That,
nice feature. It helps. Well, like when you're programming, it's a nice place. It's a nice way to do type hints and stuff like that because you can
yeah,
treat those as metadata. But it's a
yeah,
feature of the language that if it got removed, I would be fine.
I would be fine
Yeah,
too. And you print it out and read it back in, it's gone. It's weird.
yeah, yeah.
Um, if there could be some like third, like equals, but with a third option, not just true and false, it's
Mhm.
like they're the same except they have different metadata, something like
Okay.
that.
Yeah.
That would be interesting. Um, but yeah, I don't use it that much. If the provenance of the data
hmm
is important to the data model, it should be
hmm
more explicit than that.
Yes. Yeah.
It should be stored somewhere as data.
Yeah. Yeah. Right, the last thing on the list is error messages.
Error messages. Right. So he has this regret at the end that he
Okay.
said that he he wishes from the start he had paid a little bit more attention to error messages because people do learn from them.
hmm
Um, and his his statement is, he takes full responsibility, but if he could blame anything, he would blame his time as a C programmer, because in C, when you get an error, the whole system just crashes,
Yes,
and
yes.
you don't even
Sig
get an
Seg V,
error
my friend. Yeah.
message.
Or Sig Bus. Deal with that.
Exactly,
It's gone.
core dump.
Yeah.
There you go. Hex
That's a
edit that
that's a
thing.
good counter argument. Yeah, a lot of people who are complaining about error messages come from languages that are nicer with respect to that, and they didn't feel that pain. That's
Yeah,
like C-based
and
language. But
I think a lot of stuff gets confused with error messages. The stack traces,
mhm.
um, the the actual text of the error message,
Mhm.
the stack traces, and then the fact that a lot of things
Mhm.
don't check their types, right? So the error message you get is some random thing that happened later somewhere else.
Yeah,
Like
yeah.
let's say um, you pass map something that's not a function in the
Mhm.
first argument, right? It needs to be a function, but you pass it something else. And so it's lazy, so nothing happens right away.
Mhm.
And then, you know, 20 lines later, the thing tries to get the first item from the list, and all of a sudden it's like this number isn't an IFN. Yeah.
Yeah.
What?
Yeah, I
What?
remember like in the 90s programming in MFC, C++ on
Mm-hmm.
Windows. And I do remember back then, like, if you made a mistake, you would the whole thing would just crash or whatever, the train would derail and you'd be off in the field. Well,
Yeah.
even back then they had like assertions in MFC where like if you passed in something that was wrong, it would save your butt. It would say like, hey,
Mm-hmm.
what you just passed was not the right thing, or it would
Right.
catch it early during dev at least. Those things would
Mm-hmm.
disappear and get stripped out for production code, and then you'd run into the same problem like, whoop. If
Right.
it crashed hard then. But I remember liking that kind of stuff. It was like, yeah, it has these facilities that are built in for dev time to at least like it's like training wheels,
Yeah.
to catch things like, yeah, you passed in something that was just wrong, and
Right.
it's gonna cause a
Yeah.
crash if you were to like release it into production this way.
Which is what spec um,
Yeah,
instrument is supposed to do, right? You can
that's
turn
true.
it
Yeah,
on and off.
yep,
And if you had
exactly.
core
Yeah.
specs, yeah, kind of bottom out somewhere. Like at some point you have to say, like, this doesn't fit here,
Yeah.
which Clojure doesn't do. Right?
hmm
So many of the core functions don't check it to arguments, or if you give it a bad argument, it just returns nil or something like that.
Yes. Yeah.
And it would be nice to give people error messages. So I think I'm all that's to
Yeah.
say
Yeah.
is I
Yeah.
think
Yeah.
that there's a lot of confusion about like, well, this error message wasn't helpful. Well, it actually wasn't. No one ever designed that error message. There's no error
It's an
message at
artifact
all.
of what happened. Yeah.
Yeah,
It's
exactly.
you're calling this thing that you see on your screen an error message. Yeah.
Right,
It's not.
right.
It's just the train wreckage that you see
Exactly.
once it come off the tracks. It's not an error message. Yeah. Oh, yeah.
Yeah, which is, not to say that the experience that they're experiencing is invalid, right? The
Oh yeah.
beginner.
Right.
But um, as someone who's used it for so long, I've picked apart all those things in my own mind.
Yeah.
Um,
That it doesn't bother you anymore. Yeah.
yeah. I wonder if there's anything else to talk about.
I'm sure there always is. Yeah.
Yeah, we should we should probably go.
Call it a day. Yeah.
Yep.
All right.
Okay. Thanks, everybody. I'll read the outro.
See if it
Where did I put
applies.
it?
Like, don't say
Ah,
like put the thumbs up because none of that stuff's applicable.
but it will be on YouTube, right?
Oh, in the end, yeah, yeah, yeah.
Okay, so if you like the show, please subscribe. That's all I have to say. Oh, it's not going to be live, so just please subscribe.
Nothing else is
See y'all
applicable.
later,
All
everybody.
right. Later on.
Bye.